So let's now do a projection in 3 dimensions. So instead of projecting a vector onto a line in 2D, we're going to say we have two vectors. We'll say u1 and u2. And these vectors have to be orthogonal to each other. But if we span these two vectors in R3, we'll get a plane. And we're going to call the plane W. Okay, so it's just the span of u1 and u2. And if we have this vector y, they're coming out of the origin here, all these vectors. Y is not on the plane. And again, if we shine the light source down perpendicular to the plane, y will create a shadow. And the shadow is y hat. Okay. And we also have a perpendicular vector z. It's going to work the same way that it did in 2 dimensions. Y hat plus z is going to equal y. So now, how do we find the projection? We're going to use both of these vectors, and we'll just do the projection, the same projection we did in 2 dimensions. We'll just do it twice. So the formula is going to be simple to remember. You just take all the vectors in your orthogonal set and you do the projections for each one and add them together. You get the projection of y onto the plane. All right, so in this example, I've got u1 and u2 and vector y. It says observe u1 and u2 as an orthogonal basis. Let's just check. We can't do the projection if u1 and u2 are not orthogonal. So we just need to find the dot product and see if it equals 0. So the dot product of u1 and u2, so it'd be -4 plus 5 minus 1. That is 0. So that means we're good to go. It says y is the sum of a vector in W. The vector in W is the vector in the plane. That's y hat. That's the projection. And a vector orthogonal to W, that's the vector that's orthogonal to the plane. That's the vector z. So let's find y hat. It's going to be y dot u1 over u1 dotted with itself times the vector u1 plus y dot u2 over u2 dotted with itself times the vector u2. All right, so I like to set up these calculations here beforehand. Let's get everything ready for me to plug these in. All right, so this numerator here is y dot u1. So I've got y, I've got u1, just take the dot product. So I've got 2 plus 10 minus 3. So 2 plus 10 is 12, minus 3 is 9. And then u1 dotted with itself, that's 4 plus 25 plus 1, that's 30. All right, so we could divide these by 3 and get 3/10. All right, so we'll just use 3/10. The second one is y dot u2. So -2, +2, +3. So this is going to be 3. And then u1 dotted with itself, 4, 1, and 1. That's equal to 6. So this one reduces as well. So this would be 1/2. All right, so we just simplify all this. So I get 6/10, 15/10, -3/10. -1, 1/2, and 1/2. I'm going to change these fractions. Let's just do it here. Let's change these to fractions over 10. So that would be negative 10 over 10, 5 over 10, and 5 over 10. Negative 4 tenths. This would be 20 tenths and 2 tenths. So that's negative 2/5. This is just 2. And this is 1/5. So that's y hat. That's the projection. And so that's this guy, the 1 in W. So now we need to find z. So z is y minus y hat. So y is 1, 2, 3. Y hat is negative 2/5, 2, and 1/5. All right, so again, let's change these to fractions over 5. So that would be 5 over 5. This would be 15 over 5. Right, so subtract. So if I subtract these, that's minus negative 2. So it's plus 2/5. This would be 7/5. 2 minus 2 is 0. And then 15 minus 1 would be 14 over 5. So that's the vector z. Okay, so we want to write y as the sum of two vectors, one in W, one that's in the plane, that's the projection. So that's going to be this negative 2/5, 2, and 1/5. And a vector orthogonal to the plane, that's the vector z. Okay. So now we want to, let's just check and see, right? So if I add these two, I get 5 over 5, so that's 1. And 2 plus 0 is 2. 1 plus 14 is 15 over 5 would be 3. So these add up to be 1, 2, 3. So it works. And is z orthogonal to u? So you could check to see, and I can see that they are. Let me just show you. z.u1, z.u2. We need to do both of these. So I'm taking z, and I'm going to dot with u1 and u2. So 2, 5, negative 1. And negative 2, 1, 1. So see here, I get 14/5, 0, and negative 14/5. So that is 0. And here I get negative 14/5, 0, and positive 14/5. That's also 0. So it checks out. Everything checks out. This is my answer here. So this one says find the distance from y to the nearest point in W. And W is the span of U1 and U2. All right, so let's just check to make sure that U1 and U2 are orthogonal. So I get 5, negative 4, negative 1. This looks familiar, right? This is very similar to the last one, but I think they're not exactly the same. Okay, we need to find the distance from y to W, we need to find that vector z and find the magnitude of that vector. So let's do the projection first. So if you want to memorize this formula, just write it down every time you use it. Write the formula down every time, and it'll be easier to remember it. It's the same formula. You're just kind of repeating it over and over. if we were in R4, we would have 3 of these. We would just have a third one. It works out the same. So I like to set it up before I do anything, before I take any dot products. So y dot u1, so I got -5 plus 10 and plus another 10. So 10 and 10 is 20, minus 5 is 15. U1 dotted with itself, 25 plus 4 plus 1, so that's 30. So this is going to be 1/2. And let's do U2, y dot U2 be -1, -10, and another -10. So -1, -10, -10, that's -21. And then U2 dotted with itself, 1, 4, 1, so that's 6. So we could divide both of these by 3 and get -7 halves. So let's simplify. 5 halves, -1, 1/2, and -7 halves, -7, and +7 halves. So every fraction is over 2, so I don't have to change anything. But when I add these together, I get -2 halves, -8, and 8 halves. That gives us the vector -1, -8, +4. So that's my projection. So now I need to find the vector orthogonal to the plane, that's z. It's y minus y hat. Y hat's the projection. So y is -1, -5, 10. Y hat is -1, -8, 4. I'm going to subtract. So here I get 0, 3, and 6. So that's z. To find the distance from y to the plane, I need to find the magnitude of z. So 0 squared plus 3 squared plus 6 squared. It's going to be 9 plus 36, square root of 45. 45 is 9 times 5, so this is 3 root 5. So there's the distance.